Good evening. I'm Kate Shoveler, and I'm a nutritionist in the Department of Animal Biosciences, and I'm going to talk to you a little bit today about protein quality. So when you go to the grocery store and you're looking to fill your family's plate with protein-rich foods, how do you get that information and how do you choose that? Well, most of us go to the internet, and maybe we search for the best proteins that we could include. If you hit this website, you'd get your top 3 ingredients would be meat-based options. Maybe you don't want to use meat-based options, so you look for meatless protein options, which would also include dairy and eggs. Or maybe you're a vegan and you hope to not use dairy and eggs, in which case you'd be relying predominantly on beans and nuts. Or maybe you go to the internet and you ask yourself the question, what should I not include in my diet? And I call these the no-no foods. And if I added up all the no-no foods that I can find on the internet, I would guess that I would be left with almost no options to feed my family. Or maybe you go to Health Canada's new guidance in the 2018 Canada Food Guide, in which they specifically call out meat and alternatives. And these are your protein-rich category. These should comprise about 20% of your family's dinner plate. However, when we look at families and you put the same ingredients on the table, you put the same foods on the table, you get 3 very different plates. And what I'd like to draw your attention to is the fact that my son has more protein-rich foods on his plate than myself or my husband. And that makes sense because not only is he trying to maintain his body proteins, but he's also growing and depositing those body proteins. So it makes sense that he has more meat and alternatives on his plate. Now, I spend a lot of my time focusing on the pet food industry, dog and cat nutrition. And one trend in this industry is the humanization. And I hear a lot from people who are feeding their dogs and cats. Well, if I wouldn't want to eat it, why would my dog or cat want to eat it? Despite the fact that the number 2 most preferred food of feral dogs is human feces. So, I spend my time thinking about what ingredients and nutrients should we spread across the food chain. And we've done this quite successfully in animal nutrition. For example, Christine has already mentioned the fact that ruminants can salvage more nutrients from grass hays and grasses than monogastrics such as you and I. We also are very good at using every single piece of every animal that we slaughter to use each part such as byproducts. So, for example, when you see chicken byproduct on the side of your dog food bag, it's not bad. You chose not to eat it. It's a great source of nutrients. The only difference is that we've dried it and ground it and included it in dog and cat food. And then myself and many of my colleagues are looking at emerging protein alternatives, such as insects. So this led to the next step that we felt was important in looking at protein quality, which is we wanted to compare the methodologies used to define protein quality across all species and across all life stages so we could give better directions of how to allocate food ingredients across the food chain. Now, of course, this must first start with an understanding of protein quality. And protein quality generally has 3 components. First of all, an ingredient's protein content. Second, its amino acid composition, which I'm going to explain a little bit better on the next slide. And then third, the digestibility of that protein. And the digestibility is simply from what you eat, how much you can digest and absorb out of your gastrointestinal tract. But what is important is those are all ingredient-based characteristics. And we have to compare those ingredient characteristics to the specific species at a specific life stage and lifestyle to really start to optimize and provide precise nutrition across the food chain. So to understand amino acid composition a little bit better, I'm going to use the barrel analogy. So if you figure all the body proteins that I have to replace is the entire water that's in the barrel, and each slat on this barrel is an amino acid, because we don't actually require protein, we require amino acids. then I would need each of my amino acids to be 100%, the top of each one of those slats on the barrel. But in the case of beans, as an example, beans are deficient or limiting in an amino acid called lysine. So if we just tried to meet our amino acid and protein requirements with beans alone, lysine would be underprovided. But don't worry, because we have complementary proteins, such as rice. And so rice has substantially more lysine in proportion than beans do. And so when you combine them, they have a better amino acid composition together. Now, it is these parts of protein quality that really underpin things like the Canada Health Food Guide. But they also are the basis of how we get protein quality claims on our food. So you know how on milk it says an excellent source of protein, as an example. That is a data-supported protein quality claim. Canada uses a rat growth model to be able to obtain protein quality claims. In the US, they look at the ingredient quality, the amino acid composition, and they compare it to the amino acid requirements of humans. This results in the US carrying protein quality claims for specifically plant-based proteins where Canada does not. This also is included in their health food guide. As you can see in their protein-rich category, they also include dry beans and nuts, where we use meat alternatives. This led to two pieces that we've recently published. One is a commentary of colleagues of mine in industry and academia across Canada, where we made recommendations to lead to regulatory harmonization with the USA, and then we also made other commentary to bring us close to global harmonization around protein quality claims. The second piece is that we also shared our approaches in animal nutrition, and these specifically were lessons from animal nutritionists that we would give to humans to lead a healthy aging process. Our last piece will be to compare these methodologies so we can then lead to better recommendations to spread our nutrients and our ingredients across the food chain. Thank you.